In our previous two videos in the Programming the BrickPi3 and EV3 infrared sensor playlist, we discussed beacon mode, which estimates the distance between a sensor and a separate beacon based on infrared light generated by that beacon, and proximity mode, which estimates the distance between the sensor and an object by reflecting infrared light against that object. Today we'll be discussing remote mode, where the sensor interprets light generated by a remote beacon to detect which buttons are pressed on that beacon. In remote mode, every call to the BrickPi getSensor function returns a two-dimensional array of 20 elements with 5 indicators that show which of the 5 buttons was pressed for each of the 4 channels, so 5 times 4 equals 20. This first example shows what getSensor would return if the channel slider switch on the device was set to 1 and the upper left button, or the first button, was pressed. This second example shows what getSensor would return if channel 1 was selected and the second button was pressed, the bottom left button. And this is channel 1 and the large button. We would find a 1 in sensor value 04. And this is channel 2 and the large button. We would find a 1 in sensor value 14. The slide is wrong. That 11 should be a 1. That all sounds confusing, but it'll become clear when we look at the program code. Anyway, here's what our program is trying to do. When the user presses button 1 on the remote beacon, we want the robot to turn left. Button 2 means turn right. 3 means go backward. Button 4 will actually capture a photo. If the user presses the large button at the top, we want the robot to travel forward. If the user moves the channel slider to channel 2 and presses button 4, we'll actually capture a video. And pressing the large button at the top in channel 2 ends the program. So here's the code that does that. We've got our comments at the top that explain what the program's doing. We import BrickPi to get access to the infrared sensor in the motors. Import the Python time module to get access to the sleep function. We create an instance of BrickPi3, and we'll import PiCamera so that we can capture photos and video. PiCamera is our first non-EV3 accessory. Whereas the EV3 accessories are installed on the sensor and motor ports of the BrickPi card, the camera is installed on the camera port of the Raspberry Pi itself. We can take multiple photos and videos and save them to file names that need to be unique, so we have this variable called capture count that keeps track of the current number of photos or videos that we've taken, and we use that number as part of the photo file name or video file name. Next, we define this capture function to take the photo or capture the video. The caller passes a string containing the word video if we want to capture video, otherwise we will default to taking a picture. And the caller also passes the current capture count because we'll be using it, as I said, in the file name of the photo or video file, and we'll be incrementing it for next time. We use the Python with statement to create a camera object so that when we leave the block of the with statement, the camera automatically gets closed. And then if the caller indicated that we want to take a video, we use the camera's start recording, wait recording, and stop recording statements. We pass the desired video output file name to start recording. We pass a 10 to wait recording, indicating that we want a 10-second video. If the caller didn't specify that we should be capturing video, then we'll default to capturing a photo. Regardless of what type of video or photo we're capturing, the file will be written to the current folder. And finally, we increment capture count to be used in the next unique file name if the user takes another photo or video. And now that we've defined this capture function to be used later, we'll store the port numbers for the infrared sensor, the left motor, and the right motor in variables so that the code is easier to read and so that they're all defined in one place in case we need to change the program later. And here's where we set up the sensor type. In the previous programs where we set the sensor type to EV3 infrared seek or EV3 infrared proximity, For remote mode, we set the sensor type to be EV3 infrared remote. We set motor power to 30%, which is a nice slow speed. We define a function called turn motors that will indicate how much the left motor and right motor should turn. This will be called later by the turn left, turn right, and go straight functions, go straight backwards, and stop motors. Turn left turns the left wheel backwards while stopping the right wheel. Turn right does the opposite, and go straight turns both motors forward at the same speed. Go straight backwards sets both motor speeds to minus motor power, and stop motors sets both motors to 0. And here we get to the most interesting part of our program today, where we get the return values from the sensor and see how they map to particular buttons. For example, when the channel slider is on channel 1 and the large button is pressed, this first function returns true, where sensor value 04 equals 1. And this next function, button 1 pressed, behaves the same way. When the channel slider is on 1 and the user presses button number 1, sensor value 00 will be 1. Button 2 pressed and button 3 pressed follow the same pattern. The same thing for button 4, but then we see for the function called big button pressed on channel 2, the first index changes from 0 to 1, so sensor value returns 14, the 1 indicating that we're on channel 2. And the same is true for button 4 pressed on channel 2. The first value is a 1, so sensor value 13 indicates that we're on channel 2 and button 4 was pressed. So now we'll scroll down to the heart of our program, this forever loop. We interrogate the sensor and store the return in the variable called sensor value. And then we'll begin calling our functions to determine which button was pressed. And we wrote the program the way we did to make the code self-documenting. As you can see here, you can basically read each statement and understand what it's doing. If the large button is pressed on channel 1, we go straight. Otherwise, if button 1 was pressed, we turn left. If button 2 was pressed, we turn right. If button 3 was pressed, we go backwards. And if button 4 is pressed on channel 1, we take a photo. And those are all the things that can happen on channel 1. So if we fall down into this else statement, then we're not on channel 1. So we stop the motors because all of our movement takes place on channel 1. So we continue checking. If we're on channel 2 now and button 4 was pressed, that means the user wants to take a video, so we call the video function. Otherwise, if we're on channel 2 and the user pressed the large button, that means the user wants to end the program, so we break out of the loop. And finally, we call the sleep function as recommended by the BrickPi engineers, in these tight loops. And we allow the user to break out with a Control-C. And if any errors have occurred during the run of the program, hardware errors, any sort of errors, we just ignore them to keep the program simple. And again, once we're ready to exit the program, we call reset all to turn off the motors. So here's what our program does, and based on these button pushes, we turn left, turn right, turn left, take a photo, turn left, take another photo, turn right, straight, turn right again, take a video, and end the program. So this concludes our demo of the EV3 infrared sensor in remote mode. It's the last of our 3 videos in the EV3 infrared sensor playlist. Please leave your comments below, and especially if you have any ideas for future videos that have to do with programming the Raspberry Pi, please leave them in the comments below. Thanks for watching, and as always, you're the best.